Hi, welcome back to the new experiment today. And what we are going to do in this experiment today is we are going to calculate the gravity, that is acceleration due to gravity, by using a double pendulum setup. Okay, double pendulum setup, as the word says, very simple. You're going to have two pendulums attached to each other, and we are going to use this setup of double pendulum to get the acceleration due to gravity. We are going to find this by oscillating the pendulums in phase and out of phase. Okay, and we are going to find it in centimeter per second square, that is expected value is 980 centimeter per second square, but we will see what do we get at the end of the experiment. What we will need is, in this experiment, are two pendulum bobs, a thread to tie them, vernier caliper to find the radius of the bob, stand to hang this entire setup, telescope to look at the bob as you're calculating time for 20 oscillations, stopwatch. Okay, and also you will require a scale to measure the length of this thread. Okay, thread that is tied to hold these two pendulums. Okay, the formula that you will be using is just one simple formula, that is angular frequency equal to square root of acceleration due to gravity times 2 plus or minus root 2 upon L plus R. The plus sign you'll use when you are calculating for out of phase oscillation, and minus sign you'll use when you are doing calculations for in phase oscillations. Okay, and of course GLR means acceleration due to gravity, length of the thread that you'll be using, radius of the bob, respectively. Fine. So you have this vernier caliper to find the radius. Of course, you'll get the diameter, which you will have to divide by 2 to get the radius. All right, and this is the telescope that you'll be using to measure the number of oscillations for 20, time that is required for 20 oscillations. All right. So what is in phase oscillation? As you can see in this diagram, both the pendulums are oscillating in the same direction at the same time. Okay, the condition for both in this experiment is M1, both the bobs that you are using should be of equal mass, and the length, that is the distance between the two bobs. Okay, this distance and this distance should be equal. Okay, whatever is the distance L1 should be the L2. So both the lengths are going to be equal, and mass is also going to be equal. You can perform this experiment in different ways. You can take the pendulum of two different mass and same length, or you can have pendulum of same mass and different lengths, or you can have different masses and different lengths, and you can do this experiment in various ways. We have taken the easiest one. We are simply taking the lengths equal and mass equal, and we are oscillating in phase and out of phase by changing the lengths after every setup. Okay, after every reading that we are taking. So in phase, remember, you have to take the minus sign. All right, and then next you have is out of phase. I'm not able to animate this out of phase. Okay, so I've just put an arrow to show you out of phase means when two bobs will be oscillating in two different directions at the same time. Okay, what you need to take care is that there is a plus sign. All right, so remember, in phase is what you get here when it is both in same direction, and out of phase is when you have bobs oscillating in two opposite directions. So fine, we are now ready to go to our laboratory and do this experiment, and see you back once the experiment is done for the calculations. Hi, so welcome back to the new practical today. That is, we are going to find the acceleration due to gravity using the double pendulums given to you. Both the pendulums, as I already mentioned to you in the introduction, are of the same mass. Okay, and only thing that we are going to do is change the length, vary the length, and that too both the lengths will be kept equal. All right, I mean, so we will vary both the lengths L1 and L2 will be same, but it will be varied at for every reading that we are going to take. As you can see, this is the setup for the double pendulum. There is a timer given to you here, timer clock, and also you are given a telescope to look into the look at the bob. The pendulum bob that you will be focusing at will be the top bob, the top one, not the down one. So here it is focused using on the top bob. All right, so since I can see on the screen the pendulum bob moving, so I would not go that side to take my readings. I'll be looking into here on this small screen that you have next to you on the adjacent to this video here, and also taking the reading and using the timer given here. Fine, there's also one more camera fitted here to take the timings. So what we can do is we are going to vary the length in the form of 20 centimeters, 22 centimeters, 24 up to 28 centimeters, and we are going to take the readings in two manners. One will be in phase, another will be out of phase. So in phase is just that you take both the bobs in the same direction and you leave it. So this is called in phase oscillation. And the second part of this experiment is out of phase, where you will move the bobs in the two opposite directions and leave it. So this is called out of phase oscillations. Okay, so we are going to have these experiments formed into these two ways. And as you can see in the inside video, that the pendulum as oscillating can also be seen, so we need not actually go that side. But if you have to do this experiment during the practical hours, you won't be given this cameras here, so you will have to actually go at the telescope and take the readings. And the number of oscillations that we are going to take are 20 oscillations for every reading. Okay, so the first reading that we are going to do is for the length of 20 centimeters for both the bobs. So let us set it for the 20 centimeters. This particular bob can be moved up and down. All right, so for 20 centimeters, we can just take the length of 20 centimeters from this bob up to the, so 20 centimeters is somewhere here. Fine. So I just pull this bob down up to this. I just confirm it once again whether it's 20 centimeter. Fine. So a little bit lower. Fine. So this is called the 20 centimeter. And also we are going to adjust this one up to here for 20 centimeter. Fine. So what we do is just place this to here. Okay, and we bring this small cardboard that is given to you, okay, up to the 20 centimeters, and then roll the extra thread on top. So we have reached up to the 20 centimeter. Now this cardboard serves two purposes. One is to keep the measurement up to 20 centimeters, and second purpose is that it will keep the oscillation in phase, in this phase or in this direction only. If this cardboard is not there, then very likely the entire setup would start rotating around and also oscillate, so that may add to the error in our readings. Fine. So we'll just confirm once again that whether it's 20 centimeter. Yeah, so let's confirm once again whether it's 20 centimeter on both the sides. So 20 centimeter and 20 centimeter. So fine, we have set both the lengths for both the bobs as 20 centimeter, and we are now ready to take our first reading, in phase reading. So what we do is, just let me put on the camera on the timer. All right, so timer is ready. So for 20 centimeter, 20 oscillations reading we have to take. Okay, and we need to have this on our eyepiece very well set. So while setting this up, the pendulum bob has moved from your screen, so let me set that first. All right, now we have adjusted the pendulum bob, and we are ready to take the reading for the 20 centimeter bob here. I mean 20 centimeter length to the reading. Remember, your final length will be actually 21 centimeter, because we have measured the diameter of this pendulum bob, and it is to be 2 centimeter, and therefore the radius will be 1 centimeter, and therefore the length will be 20 plus 1 centimeter of the radius, and the length from here will be 20 plus 1 centimeter of the radius, and therefore the total length will be 21 centimeter. Okay, so you will have 20 centimeter length and 21 centimeter total length. So next, let's start taking the time reading. Let me put on my camera for the timer. Okay, so we are all set to take the reading. Remember, you give a very small oscillation, okay, this much, and do not give very large oscillation. Give a very small oscillation, as you can see in your video here. Fine. So as you can see in the through the telescope also, the oscillation, I can easily calculate the oscillation from here, right? So I think we can start now. I'll just give once again, since while explaining the entire oscillation got damped. So I'll start it, and I'm now ready to take my reading. So I'll press the start button on my camera. So I started. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so the first reading has for my 21 centimeter has come out to be 21. I'm sorry, 24.5, 24.57. The first reading is 24.57. So I just note it down, the first reading. Phase. Fine. Next, what I do is I need to take the reading twice so that we have an average of at least 2 readings, right? So I'll just again give a very small oscillation. This became a little too much. First, let me reset my timer. After resetting, give the oscillation again. Again, I can see the thing in the input, so I can start. So 1, 2, 3, 4, 5, 6, 7, 8, 19, 20. So the second reading for the 20 oscillations have come to be 23.50. Okay, the first reading is 24.57, second reading is 23.50. Also, at the same time, we can take the reading for the out of phase also, so that we save our time. All right, for out of phase also we can take time, otherwise you will have to do all the in phase readings and then go for out of phase. So what you can do is I can have both our observation tables ready for in phase and out of phase. Once you have taken in phase reading for 20 centimeter length, you can start taking it for out of phase too. Okay, so let me begin with the out of phase. So let me just reset my reading. Okay, so the video is on now. All right, so the out of phase, as I told you, you'll be just taking it on 2 opposite direction and releasing it. Okay, but see that out of phase is a very sensitive reading, so just give a very small oscillation and release it, and we can start taking the reading. Fine. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So stop. So first reading that I got according to my timer is 10.56. 10.56, correct. 10.56 is the first reading that I got for out of phase. Let me repeat this once again. So I'll just give a very small oscillation, release it, up, reset again, and let me start again. So give a small out of phase and start the timer immediately. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop. So it's 11.19. So second reading is 11.19 for out of phase. So I've noted down the 2 readings for 20 centimeter, which is actually equivalent to 21 centimeter, including the radius of the bob. So similarly, I go for the second set. Let me reset. Here, second set is going to be for 22 centimeter. 2 centimeters we are increasing. And attach this. Okay, let me confirm once again whether both are 22 centimeters. 22. Something got pulled down, so it became 24. Let me do again. Here. Okay, fine. So this is 22 centimeter. We are ready to take our second set of reading for in phase. Let's go for in phase first for 22 centimeter and then go for out of phase. So I give a small oscillation. Okay, again, okay, bob is still visible in our telescope, so we need not adjust as of now. So let's just push this, give it a small oscillation, very small oscillation, and start taking the reading. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop. So the second reading that I got for my 22 centimeter is 22 centimeter. Let me note down. In phase is coming out to be 26.56. Let me go for the second reading once again. Okay, so just give a small oscillation, reset, and start. 1, 2, 3, 4, 18, 18, 19, 20. So second reading that has come out is 25.8. The second reading is 25.8 for the in phase reading for this particular. Okay, so let me go for out of phase now. All right, so we are going for out of phase. Again, let me reset again in the opposite direction. Just read and start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So up at 9.23. 9.23 is the first reading. Let me stop it again and give opposite direction, reset, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop. 8.27. So I'm done with 22 centimeter. Let me go for 24 centimeter similarly. So as you know now, you have already understood the procedure. I need to go this way for 24, 26 and 28 centimeter. So let me perform all this for you quickly. All right. So recording is on. So let me reset. Now we need to do it for 24 centimeter. Okay, so we have this now 24 centimeter here and 24 centimeter here. So we need to do in phase and out of phase for this also 24 centimeter also. So you have already understood. So let me just reset and okay. So small in phase start. It's like reset. Our reading, our pendulum is not visible in the telescope, so let us adjust that first. All right, so we are now ready to take the reading as we are able to see the pendulum in our telescope. So let's start. Let me give a very small in phase oscillation and I start my reading. 1, 2, 3, 4, 5, 6, 7, 8, 17, 18, 19, 20. So this time the reading has come a little bit higher. It's around 27.23 plus. Let me just take another reading. Phase. 18, 19, 20. So this time it has come 26.75 for the third set of reading, 24 centimeter. So let me just do the 26 and 28 centimeter in the fast forward way in this video for you. Okay, so we can straight away get onto the readings. So since you have understood now up to 20, 24, 22, 24, obviously 26 and 28 would be similar. All right, so what I would do is just fast forward this particular step for you. Fine. All right. So welcome back. Let's do the calculations now. Okay, as you remember, we have of course I didn't record this part for you, but it is very obvious, okay, that for those who have forgotten about vernier caliper, remember the main scale reading, the lowest main scale reading is 0.1 centimeter. The total divisions on vernier scale is 10 and therefore the least count is 0.01. And these were the readings. It was MSR was 2, but VSR was 3 and 5. The vernier scale reading was 3 and 5. And of course, after finding the two readings and adding it up, dividing by 2, I get this was the mean value that I got, and dividing the mean value, that is a diameter now, dividing this by this, I get the radius as 1.02. Going to the calculations, I have used the lengths of in the experiment 20, 22, 24, and then I also did 26, 28, which I did not record because it would have been boring for you to watch the same thing. There is no action happening as such. It's the same thing that is happening. So the actual length is the length that I have taken of the thread plus 1.02 of the radius of the bob that is used. Okay, so that is the total length. So these are the 5 readings now. Time period up to this you have taken. Okay, this is the in phase that I'm showing you, and then these 2 I took by myself. All right, and divide this, add this, divide by 2, you get the mean time, and mean time you divide by 20 because we have done it for 20 oscillations. So we get a periodic time from that. The angular frequency you can get by 2 pi upon t. Okay, so take 2 pi and divide it by the t value that we have got here. Very simple. Then square it up, you get omega square, and then find the inverse of this length that you have found here. Okay, just find 1 upon L, and these 2 values are the ones which you are going to use to plot the graph. All right, so in the graph you are going to use the omega along the y-axis and this along the x-axis. Okay, also let's see the readings of the out of phase. For out of phase, again the lengths are same, and the same lengths we used, and time period decreased to almost half than what we had got, and this was the mean. Okay, you can see there is some trend, except this small reading. This second reading I think is little wrong because it came little below than all other readings that we got. Periodic time is, take the time divided by 20, you will get this, and omega is equal to 2 pi upon t, where 2 pi upon this you can get omega square. The same thing that you're doing. Again, we are going to use this along y-axis and this along x-axis. Okay, so this is what I got after plotting the graph. I have that reading which was coming too small, this one 8.75, led to a big error here, you can see, in the out of phase. So I've ignored that reading while plotting the graph, and I've taken these 4 points to plot the graph, and these all 5 points were perfect here in phase. And the slopes that I got for out of phase is 2863.6, and slope that I got for in phase, red one is in phase, you can see the red one is in phase and blue one is out of phase, is 569.14. So after doing the calculations, you can see G equal to how I got this calculations. So this one, if I can show you this formula. All right, so if I square on both the sides, I will get omega square. Okay, and then G can be written as equal to L plus R upon 2 plus root 2. Okay, all right, so omega square L plus R, so L plus R can be brought to the denominator, it will be 1 upon L plus R. So this slope in your graph is nothing but omega square, that is y2 minus y1 upon x2 minus x1, that is omega square upon 1 upon L plus R. Okay, so this is the formula. So let's go back to the calculation, and so that's how we get this G. So using that slope that I got here, I get a 971, which is a very good reading. Okay, very good reading, because 980 is what we were expecting. And out of phase reading has gone little bit off, it is 838. Maybe we can put it on this point that has gone wrong, as you can see. Okay, maybe because of this error has come, which is 838, which is also okay, fine, no problem. Okay, so readings are come quite good in phase and out of phase. There are a lot of errors that can come in while taking the readings. The fans are on, therefore the pendulum oscillates little, there's a disturbance, and so many things that factor affects our reading, but I think these readings are quite good. All right, and therefore the final results will be in phase is this one and out of phase is this one. Okay, we won't add and find the mean because it won't give any great correction to it. In case this was little higher, on a higher side, like say like 1000 or something, then I would have said let's add this, divide by 2 and get the average, because then the average would have come very close to 980. But that won't happen in this case because this is very low, almost 150 lower than what we expected. Okay, fine. So this final reading, so not bad, very good readings. Okay, so I hope you have enjoyed the experiment. It's a very simple experiment. Calculations are also very easy. Graphs are there. So I think in total it should take 1.5 hours to do this full experiment. Okay then, thank you, and see you for the any other experiment.